Hello everyone, it's Eddie again here, and in this video I'm going to walk through how to set up a PLC project using a Compactlogix PLC with Studio 5000 that can talk to a variable frequency drive. We can also have two PLCs talk to one another, and we can also talk to a robot. So to begin with, I'm going to give you a quick tour of the hardware. So first of all, we have ourselves a robot controller, and I apologize for the camera here. It's a new setup for me, so I'm just checking it. So this is our robot teach pendant for a Fanic robot, which you can see over here. That looks better. Walk a little closer. We can see we have this PLC here on the left. In this one, we're going to give it the nickname Bread because I like giving things fun names. And it is connected to an Ethernet switch down here. And there's this black cable that you can see running to an Ethernet switch over here. This Compactlogix PLC is called Raisin. It's going to be our main one. And that's going to be the kind of the big bulky box on the upper left of the black case is the PLC itself. Again, Compactlogix Allen Bradley PLC. There's a frequency drive on it, which is in the lower, kind of the lower right. It's the Power Flex. And then in the back we have our Fanic robot. And every one of these is hooked into this Ethernet switch on this box, which connects to this Ethernet switch on this box, and that is the hardware setup. I've also gone ahead and configured the IP addresses of all these things. So what we're going to do in this particular video is get all of this loaded in Studio 5000 so we can then begin to get everything talking. So I'm going to create a new project in Studio 5000, which is the software used to program Compactlogix PLCs and Controllogix PLCs. And they are much better at Ethernet communications, which makes them really ideal for Internet of Things and SCADA ignition type projects. So this is a 1769 L36 ERM Compactlogix 5370 controller. And like I said before, I'm going to call my main one Raisin, so I'll get that one started first. I'm going to hit next. It'll be revision 38, and I will hit finish. And we'll get that project going here in a second. And here it comes. And as I've said, I've gone ahead and assigned Ethernet addresses to all the devices. If you want to come in and do this in person, is this something you need to ask? And there's also a lot of documentation out there. It's not terribly hard to do, but it is a big part of this. So I have my Raisin PLC. So I'm going to go ahead and get that connected. Or go to Communications Network Browser, and older versions of Studio 5000, it'll say Who Active. And I'm going to look for 192.168.1.10, which is currently named Banana, because I like fun names, and sometimes students like fun names. And I'm going to go ahead and hit download. And download again. And that just kind of wipes everything in the controller. It's not really a great idea To do that, if you're in a production, like factory facility and you're updating things, but in a lab context, starting fresh is totally fine. I'm going to start another instance of Studio 5000, do a new project, same PLC type, a 1769 L36 ERM. I'm going to call it bread and hit next, finish, and it will get going for me. And in this case, what I'm going to do with bread is I'm going to kind of set it up a little bit further. I'm going to go ahead and go into network browser. I'm going to do a fresh download to it. So that's going to be the one 192.168.1.7, which is currently named Blueberry. So I'm going to download to that, which will, you can see this one has already been renamed Raisin. This one will be renamed to Bread. We can do a download. Remember, a download means you're sending the data from your computer down to the PLC. So in Bread, I'm going to go ahead and go offline. I'm going to right click in Ethernet, click on new module. And I want to go ahead, and the first thing I want to do here is add in the Raisin PLC, which will allow them to talk. Again, there's a physical Ethernet cable connecting one PLC to the other, which is important. So if I just type in L36 ERM, I'll hit create, and I'll name it Raisin. That's what we want to find. And it's going to be 192.168.1.10 is the address of Raisin, and I'm going to hit OK. And you'll see that it is added on the left as another Ethernet connection. So in here, I'm going to click on controller tags, go to edit tags. I'm going to create a new tag that's going to be called to_Raisin. Going from bread to Raisin. We're going to leave the data type a double integer. I'm going to right click and go to properties. And I'm going to change the type to a produced tag, which means it's going to send data out. And for connection, I'm going to leave it at one consumer maximum. So only one other PLC can read this data at any time. I'm going to hit OK. And in this case, I'm going to put a value of 55. And then I'm going to download it. And it'll switch into remote program, and then it should go into remote run. And now I'm going to sort of minimize that. I'm going to go into the Raisin controller, which is going to be my main one. And I'm going to take it offline. I'm going to right click. And again, I'm going to add in a new module. And in this new module, I'm going to I'm going to look for an L36 ERM. Hit create. I'm going to call it bread because that is where it's coming from, and it is from 192.168.1.7. That's bread's address. I'm going to hit OK, hit close, and I'm going to go into controller tags, and I'm going to create a new tag called bread _to_Raisin. It's going to stay a DINT. It's got to match the data type. And I'm going to right click go into properties, change it to a consumed tag, meaning it's going to use up a produce tag, and the producer is going to be bread, and the name of the remote data is going to be 2_raisin. So that's the exact name that it is in the bread controller. So I'm going to hit OK. OK. You can see right now it has a value of 0 because we are not online and so the connection isn't valid. But if I download and go online, we're going to see that it should update to 55, which is the value we put in bread, and indeed it does. And if I go back to the bread PLC, controller bread, and I change this to 355, and then I go back to the raisin PLC, I might have to press enter. You can see the raisin PLC updates. So now they are talking, so the raisin PLC can read what's in the bread PLC. And that's called implicit messaging, where they're kind of meshed together. We can also send an explicit message, which is a programmed message in the PLC program that kind of sends like a text message to the other PLC. This is better because it tends to show that it is connecting a little bit clearer. So let's do the frequency drive next. So I'm going to go offline, and I'm going to do this all in Raisin now. New module. And the type of PLC that I have is a PowerFlex 40. So if I kind of expand these out, PowerFlex 40E so it's going to be over the Ethernet communications. We're going to create it. And the name of it, we're just going to call it VFD. It's a variable frequency drive, meaning it can be used to control motor speed and direction using pulse width modulation. And the IP address that we've assigned to it is 14. So I'm going to make sure that that is entered. And that is the current revision. And that is the drive rating. So I'm going to hit OK. And we can see that there are parameters that we could edit. There are 167 parameters that we could adjust. The main ones for a PowerFlex 40 is we want 36 and 38 to have the COM port value, which is internal value 5. So I'm just going to go ahead and hit create. And that adds that into the system. And I'm going to switch over to my phone camera here. And I'll see if I can get us closer. I apologize for the blurry video. But you can see that it currently is showing an error. To clear that error, I'm going to first move my computer a little bit closer so I can reach. And I'm going to go ahead and hit that off button to clear it. And If I go back to the PLC screen now, and I want to go to my Raisin PLC, we'll see that we have a VFD output and a VFD input. That's an output to the VFD or an input from the VFD. If I go ahead and download again, I can change this to start, which should start my VFD up, and I did hear it start up. And then this is the frequency command, which accepts an integer from 0 to 600. So if I set it to 75, what we can see, if I go back to my phone camera here, is now the VFD is reading a frequency of 7.5 hertz. And if I were to change that to 400, we can see on the phone camera that it is now 40.0 hertz. So that means that from our PLC, we are able to get very good control of the frequency drive just by adding it into the program like we just did into the Ethernet. So the last thing we want to do is we're going to go offline one last time, and we want to add in the robot. So I'm going to do another new module. And in this case, we're going to look for a FANUC robot. So FANUC, and the one we want is the R30IB Plus because that's the type of controller we have. So I'm going to do a create, and I'm going to call it robot. And the IP address for this guy is going to be 192.168.120. And I'll close out. And we can see that once again we have, I'll get rid of these, we have robot inputs and robot outputs. Again, robot outputs are outputs to the robot. Robot inputs are inputs from the robot. So for this one, to kind of show what this looks like, I'm going to do a bit of a split screen. So this is my robot controller here, as well as the PLC. If I go into I/O and then hit type, and then look for digital inputs and outputs, and then I'm going to scroll down to digital output 121. Which we can see here. And for my robot input, remember that's an input from the robot. If again I download this and then go online, we're going to see what happens when we start triggering these inputs and outputs. So for this input from the robot, if I go ahead and turn digital output 121 to on, we should see that in the PLC, this robot input has changed to 1. And if I change this to on, in the PLC, this other input has changed to 1. So digital input output 122 becomes on. So anytime I turn those outputs on in the robot, these inputs will turn on in the PLC. allowing me to communicate back and forth. Similarly, if I go to the inputs page of the robot, the DIs, and I'm going to scroll down to digital input 121, on the PLC robot output, if I change the first robot output to a 1, we'll see that that digital input turns on. And if I change the next robot output to a 1, digital input 122 turns on. So what that means for us is we can do handshaking between the robot and the PLC. So robot PLC inputs PLC outputs can turn robot inputs on, and robot outputs can turn PLC inputs on. And that allows us to do all sorts of things in the robot program as well as the PLC program. And we can also have that data read up to a SCADA system. So for this video, that's all I wanted to cover. We just integrated 3 devices, PLC to PLC communications, PLC to frequency drive, and PLC to robot. And all of that can then talk to a SCADA system like Ignition or something similar in order to track all of that data across our whole system that we're building over Ethernet. So hopefully this made sense, and you are well on your way to building really cool Ethernet networks on your own using Studio 5000 and Compactlogix PLCs.